Welcome to this explainer. Look, if you're an infrastructure executive or a transit authority leader, you already know that keeping our transportation networks running isn't just about building them in the first place. It's about making sure they actually survive. So today, we're breaking down what makes modern road tunnels truly resilient. And we're going to do that by looking at an absolute game changer of a material, vitreous enamel, or VE panels.
We're basically redefining the whole concept of a modern tunnel here. It's no longer just about static structural rigidity, just building thick concrete walls and hoping for the best. True tunnel resilience, as we'll see today, is the capacity to absorb environmental shocks, maintain daily operations, and crucially, recover rapidly from catastrophic incidents. It's shifting from a passive structure to an active, defensive environment.
Okay, let's dive right into this strategic briefing. We're going to systematically break down resilience into 5 key pillars today. First, the new paradigm of tunnel resilience. Second, extreme fire and post-disaster recovery. Third, zero disruption smart maintenance. Fourth, lighting, energy, and driver safety. And finally, life cycle cost and finance.
All right, Section 1. The new paradigm of tunnel resilience, or what we like to call an active defensive skin.
Let's be real, road tunnels are incredibly harsh environments. Day in and day out, they're filled with continuous vehicle emissions, high humidity, highly corrosive gases, relentless acoustic vibrations, and just heavy soot. Concrete alone simply cannot withstand that over decades without degrading. It needs an active defensive skin. Enter vitreous enamel, or VE. This stuff is forged in absolute extremes. Liquid glass and a low-carbon steel substrate are literally molecularly fused together at insane temperatures, between 800 and 850 degrees Celsius. The result? A highly engineered composite material that gives you the structural tensile strength of steel, completely combined with the absolute chemical inertness of glass. It's a game changer. Moving on to Section 2, extreme fire and post-disaster recovery. Because at the end of the day, life safety is the ultimate priority.
During a catastrophic tunnel fire, every single second counts, and this is where VE panels really shine. They hold an EN 13511 Class A1 certification. Now, because they're made entirely of inorganic raw minerals, they are 100% non-combustible with zero fire propagation. But here's the absolute most critical part. They emit zero smoke and zero toxic fumes under extreme heat. For transit executives, this changes everything. It means you are preserving critical visibility and breathable air for commuters trying to evacuate and for the first responders running into that chaotic environment.
30 seconds. Honestly, this is just a jaw-dropping engineering statistic. Think about it. During a severe tunnel fire, temperatures spike massively, right? But when first responders arrive and hit that intense fire with high-pressure water, the environment experiences an immediate, brutal thermal shock. Well, VE panels are engineered to withstand a staggering temperature drop from 400 degrees Celsius straight down to ambient room temperature in just 30 seconds. No cracking, no warping, no delaminating. It's incredible. And to put that into perspective, traditional materials like plastics, aluminum composites, or heavy paints, during a fire, they often emit toxic fumes and can suffer explosive structural failure, which leads to massive concrete spalling and brutally long recovery downtimes. V panels, on the other hand, safely absorb that thermal shock. And the crucial takeaway here isn't just about the panels surviving the fire, it's about protecting the underlying concrete so you can conduct ultra-fast post-incident inspections and get that tunnel reopened to traffic almost immediately.
Okay, Section 3, Zero Disruption Smart Maintenance. Let's solve some of those daily operational headaches.
Shifting from disaster recovery to daily operations, we really have to talk about the massive headaches and costs associated with manual tunnel maintenance. VE panels have a Moss hardness scale rating of 5 or higher, meaning they easily resist impacts and scratches from flying road debris. But the real magic? It's the anti-static glass surface. It naturally rejects the accumulation of static dust, microscopic soot, and heavy exhaust grease. Plus, it forms this impervious, non-porous barrier. That means industrial graffiti or adhesives simply cannot bond to it. You can chemically wipe it away 100% of the time, and it won't degrade the panel's gloss or integrity at all.
So how does this actually translate to your workflow? Well, these defensive properties completely transform how you maintain the tunnel. First, you just deploy heavy mechanical rotating brushes. Next, you blast the walls with high-pressure automated water jets and chemical solvents. Because the VE surface is so incredibly tough, it withstands this aggressive automation seamlessly. The result is rapid, highly efficient cleaning cycles with zero traffic disruptions. You are completely eliminating the need for prolonged tunnel closures or incredibly expensive manual scrubbing crews.
Let's shift gears to Section 4, Lighting, Energy, and Driver Safety. This is where eco-resilience meets human factors.
Have you ever driven into a tunnel on a super bright, sunny day and suddenly slammed on your brakes because the entrance looked completely pitch black? Yeah, that's called the black hole effect, and it is a massive human safety hazard. Well, VBE panels installed at the tunnel threshold feature extremely high optical reflectivity. They maximize the transition lighting, illuminating the walls and smoothing out the driver's visual adaptation to prevent that sudden, dangerous braking. And similarly at the exit, semi-gloss panels are used to prevent the blinding white hole effect as drivers safely re-enter natural daylight.
And this specific optical engineering connects driver safety directly to decarbonization. Because these high-gloss and semi-gloss finishes diffuse light so evenly across the entire tunnel envelope, engineers can substantially reduce the total number of lighting fixtures required inside. Fewer fixtures mean continuous, massive electricity savings for the transit authority. So you're directly contributing to your energy efficiency and sustainability goals while actually making the road safer. Finally, Section 5, Life Cycle Cost and Finance. The absolute bottom line on resilience. All right, it's time to tie all these safety, maintenance, and energy benefits directly into your long-term financial stability. And we need to do that by deconstructing the myth of low CapEx. Look, traditional paints, concrete sealers, or cheaper metal claddings, they might look fantastic on an initial procurement budget, but they create high, wildly unpredictable OpEx. Constant repairs, manual cleaning crews, and structural degradation quickly deplete public budgets over time. The resilient financial alternative proves that a slightly higher upfront capital expenditure on premium VE panels actually yields an ultra-low, completely predictable operational expenditure curve over the life of the asset. When we actually stack these multi-material life cycles side by side, the bottom line becomes incredibly clear. Paint? It gives you maybe 5 to 10 years, with high operation and maintenance costs and, honestly, pretty poor fire safety. Ceramic tiles or bare concrete might last 10 to 15 years, but they require frequent manual scrubbing and constant grout repairs. VE panels, however, give you that Class A1 fire rating, ultra-low automated O&M costs, and essentially full ROI within the first few years of operation by virtually eliminating recurring replacement costs and tunnel downtime. 30 to 50 plus years. Let that sink in. VE panels are formulated with inorganic mineral-based pigments, meaning they suffer absolute zero UV degradation. None. They remain entirely color-fast for decades, whether they're baking under bright portal sunlight or sitting under artificial interior lighting. This kind of empirical longevity ensures that this active defensive skin matches or in many cases even exceeds the design life of the tunnel asset itself. So, I want to leave you with this final provocative thought. Is your infrastructure designed just to stand, or is it actually engineered to recover? As we've seen today, surviving a catastrophic fire, smoothing out driver visibility, and completely eliminating disruptive maintenance closures, it's all about operational resilience. When considering the legacy that infrastructure planners and transit authorities are leaving behind, treating your tunnel walls not as a static, passive surface, but as an active, resilient shield, well, it isn't just a nice-to-have upgrade, it's a necessary strategic asset. Thank you so much for joining me for this explainer, and I really hope this empowers you to build smarter, safer, and infinitely more resilient infrastructure for the future.